Please like and subscribe.
Resources, people, facilities, equipment, investment. Applied imaginatively on a massive continuing basis, working toward a common set of priorities. More efficiently and economically move a vehicle from point A to point B. Coax a Chevrolet a little bit farther on a little bit less fuel. Increase and stretch and lengthen miles per gallon. Squeeze a final ounce of energy from precious, non-renewable resources. Or find alternate sources of power to redefine automotive propulsion as we know it. Steam power, solar power, electric propulsion. Each holding out the hope of being the Chevrolet power plant of tomorrow. But as promising as some are, not one new power source offers the full range of customer benefits of efficiency, economy, response, durability, and dependability found in the greatest power plant ever conceived, the internal combustion engine. At this time, it is the best power plant available to drive an automobile. The engines in Chevrolets are on the leading edge of automotive technology through advanced diesel engine design, and for gasoline engines with sophisticated energy management systems like onboard computers. All help make the internal combustion engine even more efficient, more responsive, more of what today's customers need. Many featuring breakthroughs that are totally new, and many that reflect prior improvements based on ongoing breakthroughs in technology. Breakthroughs like computer command control. The heart of all gasoline engines used in Chevrolets. Computer command control continually monitors information from up to 12 sensors or information centers, including the throttle position sensor, the coolant temperature sensor, the exhaust oxygen sensor, and the manifold vacuum sensor. The computer receives this information and then makes precise adjustments in up to 8 powertrain systems, such as the fuel system, the electronic ignition timing, the air system, the engine idle speed, the fuel evaporation control system, and the torque converter clutch. The system makes thousands of adjustments per second to fine-tune the engine. For example, it can adjust the carburetor fuel flow up to 10 times per second for the correct fuel mixture, and automatically helps compensate for changes in altitude. The system is also self-diagnostic. That is, the cause of a malfunction in the system is stored in the computer's memory and then fed back or signaled to the technician so he can quickly determine what must be repaired. In the unlikely event of a problem in the system, the driver is alerted by a check engine warning light to take the car in for servicing. Computer command control represents advanced technology in automotive engineering. It reduces exhaust emissions, allows for good fuel economy, continually fine-tunes the engine under normal operating conditions, is self-diagnostic, and as with all emission systems, it is backed by a 5-year, 50,000-mile performance and reliability limited warranty. Another engineering advancement is throttle body fuel injection. A fuel injection system for 82 that's controlled and monitored by computer command control. Throttle body fuel injection is standard on all 2.5-liter 4-cylinder engines, and a dual system is featured on Camaro Z28's 5-liter V8 and Corvette's 5.7-liter V8. This is a high-technology fuel injection system, a future wave of fuel metering systems offering good fuel economy and impressive performance. This fuel injection design replaces the carburetor, including the choke, float bowl, all fuel circuits and venturis, with a solenoid fuel injector, the heart of the system. It's an injection unit electronically controlled by computer. Let's see how the system works. During engine operation, air is drawn from the outside through the air cleaner and enters around the solenoid. The computer command control system immediately determines the proper mix of fuel and air for the driving condition and signals the solenoid to inject the precise spray of fuel into the throttle body where it mixes evenly with the airstream. This system can make adjustments in the fuel flow as often as 80 times a second to accurately maintain the desired mixture under varying operating conditions, adjusting for differences in air temperature and atmospheric pressure to give you a high level of energy from each drop of gas. And with this system, engine idle speed is automatically controlled and never needs adjustment, so the need for conventional carburetor tune-ups is eliminated. Vapor lock and dieseling are virtually eliminated. The dual crossfire fuel injection system operates on the same principle as the single fuel injection system. Mounted on a lighter weight cast aluminum ram-tuned manifold are two complete fuel injection units for added fuel control to the cylinders. The manifold has a cross-flow pattern. That is, the mixture fed from the throttle body on one side is directed to the cylinders on the opposite side. This helps provide the combustion chambers with the same amount of mixture for a fast, even combustion in all the cylinders. The dual system shares the benefits of the single system and increases horsepower by approximately 5% over the 5.7-liter V8 four-barrel carburetor engine used for Corvette last year. It also contributes to good fuel economy and contributes to a smooth-running engine. Another engineering advancement for 1982 is swirl induction, a technological advancement for Chevette's base 1.6-liter four-cylinder engine. This system swirls the air and fuel, providing high cyclonic action to evenly distribute the air-fuel mixture throughout in the cylinder. Then it is compacted, like a spring, by the upward movement of the piston, to evenly spread the air and fuel throughout the cylinder. When the spark plug ignites, this mixture burns more completely to drive down the piston with increased force. Compared to the conventional system, this swirling process permits usage of a higher compression ratio of 9.2 to 1, contributes to impressive fuel efficiency, and increases torque for impressive acceleration at low and intermediate speeds. This year, Chevrolet offers the engineering sophistication of a 5-speed manual transmission available on 1982 Chevettes. This sporty 5-speed has an overdrive ratio to give good fuel economy. First through fourth gears give good acceleration and have close ratios, allowing for smooth shifting performance. And the fifth gear is an overdrive ratio that enables the car to maintain highway speed at less engine RPM than a conventional 4-speed manual transmission without overdrive. The 5-speed manual transmission helps provide impressive fuel economy and helps reduce engine noise. Another efficient drivetrain feature is torque converter clutch. For 1982, overdrive automatic transmission, now available on all gasoline V8 Caprice Classic and Impala models and Corvette. This transmission offers the benefits of an overdrive gear ratio, previously only available on manual transmissions with the convenience of an automatic transmission. To illustrate how the overdrive automatic transmission works, we installed a special speedometer and tachometer in a Chevrolet Caprice Classic. As it shifts from first through third gear, the readings are similar to a conventional 3-speed automatic. But when the Caprice Classic reaches a cruising or highway speed, you will feel the transmission automatically shift into overdrive. For high torque requirements, such as for passing, the transmission automatically downshifts into third gear. Once the steady speed is re-established, you will again feel it shift into the efficiency of overdrive. At highway speeds, overdrive automatic transmission reduces engine speed by nearly 1/3. helps increase fuel economy and reduces engine noise. Computer command control, throttle body fuel injection, swirl induction, torque converter clutch, 5-speed manual overdrive transmission, overdrive automatic transmission. All major technological advancements, the work of engineers and scientists dedicated to help make the gasoline engines used in Chevrolets more efficient, more sophisticated, to squeeze additional energy out of every drop of fuel, to meet the needs of today's buyer. But the technology story does not stop here. Chevrolet has recognized that there are people with special power plant needs. People who want an internal combustion engine that gives them high energy from every drop of fuel, whose driving requirements demand a lot of long-distance driving. For them, the logical choice may be diesel power. Diesels share many characteristics with gasoline engines, such as cylinders, pistons, and valves. But there are key differences in a diesel, such as fuel injectors, pre-combustion chambers, electric glow plugs, thicker walls, and heavier-duty components to withstand the tremendous heat and pressure. To better understand the differences between the gas and diesel engine, let's first see how the gasoline engine works. On the intake stroke, the mixture of gasoline and air is drawn into the cylinder. On the compression stroke, this mixture is squeezed to about 1/8 of its original volume. At the beginning of the combustion stroke, this highly volatile mixture of gas and air is ignited by the spark plug, and the explosion forces the piston down. The diesel engine burns fuel in a different and more efficient way, without the use of spark plugs. At the start of the combustion cycle, the cylinder is filled with air as the piston moves downward. The air is then compressed by the piston to 1/22nd of its original volume, generating tremendous pressure and heat, approaching 1,000 degrees Fahrenheit. The less volatile diesel fuel is then injected, and because of the extreme heat of the compressed air, ignites instantly without the use of a spark plug, burning evenly and more completely. The diesel engine burns fuel so efficiently that a diesel-powered vehicle gets substantially more miles per gallon than a comparable gas-powered vehicle. And diesel fuel traditionally costs less than gasoline. Diesel, the most efficient internal combustion engine. It's no wonder diesel engines in passenger cars are selling at a record pace. 500,000 sales expected in 1981. And for 1982, Chevrolet will be one of the leading sellers of diesel engines in the world. Chevrolet's diesel lineup includes, for Chevette, the available 1.8-liter four-cylinder diesel. It represents modern diesel technology, tested over 1.25 million miles and 25,000 hours in the lab. For Malibu Classic and Monte Carlo, the available 5.7-liter V8 diesel will be offered at start of production. An all-new 4.3-liter V6 diesel will replace the V8 later in the model year. Both offer a degree of economy never before available. And Impala, traditionally America's best-selling full-size cars, the available 5.7-liter V8 diesel provides good fuel economy. And for the Chevrolet Celebrity, the all-new 4.3-liter V6 diesel will be available. A wide choice of diesel power for Chevrolet cars, from the smallest to the largest. One more reason why Chevrolet stays a step ahead. Chevrolet has continued to respond to changing transportation demands with diesel and gasoline power, all to make the internal combustion engine use energy efficiently and powerfully, to make Chevrolet the kind of car that meets the needs of today's buyer.